since I know we are already in here, so we make sure everyone is participating. So, class,
Yes.
tree.
Yeah.
There we go. We got a tree, so we're good. All right. So, derivatives of logarithmic functions. This is usually the bane of most people's existence because they hate logs. Now, I agree. They kind of suck.
In there.
It's kind of like that college placement test that you took.
Yeah, but
It was all those formulas that you were supposed to know.
no, but relating to this,
It's just a cone.
we didn't
It's like
do
ice
this in
cream.
homework either.
All right. Anyway.
Mark me off for this.
Herman?
No, excuse me for this one.
What?
I don't know this one.
Okay. Anyway, recall the following statements are equivalent. So logarithms, right here, log base a of x is equal to y. If and only if, you could rewrite it in this form right here in exponential. Everything in math has its opposite. So the opposite, to undo it, to undo a log, I get exponential. And goes back and forth. So, right here, we have two formulas for log and ln for the derivatives. Now, if you look right here, the derivative of log base a of x is 1 over x log ln a. For the derivative of ln, it's just 1 over x. And I'm going to show you why that still works. So it's going to work for both of them. So 1 over x ln a, so log base a of x. So, isn't ln, isn't that a regular, that's a log, isn't it?
Yeah.
But that's a log with what base? It's a log base e. Okay, if you forgot that, it's fine. So I'm going to, y equals, so log base e of x. So ln is just log base e. Yeah? Okay, good. So using that information that you just had, the derivative, so y prime is equal to 1 over x ln of a, but what's the a in this case? And what happens if you get ln of e? I get 1. The ln of e actually just goes away because it's 1 times x. So, if there was anything you were going to try and memorize, I would memorize the formula for log base a. Because ln is just the same thing, but ln e cancels. All right, so let's go ahead. All right, soldier boy, what am I going to do with this one here? U. So I'm going to say that u ln x is equal to u. U prime is 1 over x. So as I write it, I get u squared is going to be 2u times u prime. So y prime is going to be 2 ln of guys okay with that? All right, so next one is 1/2 log x. Bless you, I think. If there is no base on a log, what is my base going to be? What? 10. So if you just see log by itself, it is base 10. So my a value there is 10. All right. I don't have anything crazy to do now because it's 1/2 times, this is my coefficient, this is the number out front, just going to be times whatever we have. So y prime is going to be 1/2 times, the derivative is going to be 1 over x ln of 10. Little rules about the logs and ln's. If you did not remember it off the top of your head, make sure you write it down, underline it, so you're going to have to come back to it later. What does C say? ln x ln y equals 2x. Oh wait, no. All right, just looking at this, what type of problem do I have here? What? I have an implicit because I have a y in my function now. So whenever I'm taking a derivative of y, I need to add a, yeah, dy dx, very good. So derivative of ln x is 1 over x. Derivative of ln y is 1 over y dy dx is equal to 2. Now I want to start doing a little bit of subtraction here, so I'm going to subtract 1 over x from both sides. Y dy dx is equal to 2 minus 1 over x. Multiply both sides by y. So I'm going to get dy dx is equal to y quantity of 2 minus 1 over x. Good? Not too crazy, right? Last one. Y equals log base 2 of x cubed. Alright, soldier boy. What do I have to do first to be able to do this problem? No, you gotta say it the right way. U! Alright, so we gotta U this. So what's my U? Yep. So I'm going to rewrite this now as y equals log base 2 of u. Y prime is going to be 1 over go ahead. So y prime is going to be equal to 3x squared over x cubed times ln of 2. And I could do a little bit of boop, boop. There you go. I just cleaned it up. The x squared to the x cubed. So, what example was that? Is that still my first one? Yeah. Alrighty. So, chain rule, or we just call it Soldier Boy, right? Because that one's more catchy than 2 chains, or wasn't that guy like a rapper, like 2 Chains or something like that? Got 2 chains, yeah, something like that. Yeah, but it's not as memorable as you. Anyway. Okay, there we go. All right. So this one right here, same thing. So I'm going to say that u is 5x, u prime is 5, y equals ln of u, y prime is going to be equal to 1 over u times u prime. As soon as I get to that side of the board, it starts messing up, getting all weird. It's like it's running out of ink on that side. Maybe I just used it too much. One over u, which is 5x, times u prime, which is 5, which is going to give me a grand total of next one here, it's going to have a product and a chain, right? Okay. X ln x squared plus 1. Yeah, there we go. Wrong way. There you go. Okay, product rule. So let's go ahead and do the product rule. So this is my f. So f prime is 1. So y prime is going to be 1 times ln of x squared plus 1 plus sign x times derivative of ln of x squared plus 1, but ln has this, which might as well just call it a u, right? And derivative of, so ln of u is going to give me 1 over u. Over u prime. And then let's put it back in together. to x times 1 over u, so it's 1 over my u, which is x squared plus 1. So hopefully makes that a little bit easier to multiply together right there. Y prime is equal to ln of x squared plus 1 plus 2x squared over x squared plus 1. Questions on that one? No? And this one right here, absolute value of x. So it's just going to be and guess what? I'm going to leave off here before we go too much further and get into the crazy stuff where, ooh, I didn't need the absolute values. But it is necessary sometimes to simplify work, find the derivative. So I didn't need the absolute value on that one. So apparently I did not need the absolute value. I think it's on the integration one where it's always necessary. Yes, the antiderivative always has that. Okay, so again, before we go through and make some more mistakes, I'm going to leave off here and make sure everyone's going to like, share, and subscribe, right? They hit that notification button. And again, my merch store is closing down soon. So if you want something, you got to get it now.